Hi there friends, here is one of the most important chapters in C. I am taking that off, and a chapter which is not so frequently discussed or taught, but let me tell you, this chapter serves as a foundation for you when you get into any kind of development line, when you get into a career related to programming, because this is about file IO, file input output. So let's go on with the chapter. See, let me tell you one thing. Till now, what we have been discussing in C is, things like arrays, variables, pointers, storage class, all these chapters. What we went through was something called variables to store data. When it is multiple variables, multiple data values, we used arrays or strings or maybe structures we use to store data. Alright, but when it comes to storing data permanently, I need a file, because all these things like a variable or an array or a string, they can hold data temporarily. They will never hold data permanently. So if I want to store data permanently, what I need is a file. Alright, so let's go on. First thing about a file. Let me tell you, file handling in C. In C language, when you handle a file handling, the entire process, it's called this. And please remember, this is very, very important. This one sentence, it's called buffered file IO. Buffered file input output. What is a buffer? Temporary storage, a logically bounded memory area where operations take place. What kind of operations? Input output operations. You have keyboard buffer, you have a display buffer, you have different types of buffers are there. They are nothing physical, they are logical. They are a part of memory, but they are logically created. Remember this. Well, some sort of physical buffer might be there in case of some systems, but here we are talking about buffered file IO. That simply means any kind of input output which is taking place through a file is through buffered file input output. Got that? Here is a diagram. Look at the diagram of buffered file IO. It's a very simple diagram to tell you how this file IO takes place through buffer. Have a look. Got it? Memory, buffer, disk. Alright, disk to permanently store the data. Alright, it is also known as secondary storage, if you remember. Got it? Clear? Buffer is that part where before reading or writing, the IO operation we are talking about, either reading or writing, input or output, whatever you talk about. Alright, in between you have buffer. Now look at memory, look at disk, they are at their own place. But what is there? When you input something, it goes into input buffer. When you try to output something, it goes into the output buffer. Now big question is, why buffer? Very simple. Memory is a big area, huge area. If I am talking about memory, then I'll be lost simply. Data will be there in memory, no doubt, but if it is buffer, as I said, it will have a logical boundary. For example, if I tell you, I give you a big area and I say, look for this thing in this area, a particular thing. It's a big area, huge area. So what happens? It takes a lot of time for you to search in that area. But if I give you a boundary, that is a big area, but I say, look at that east corner over there within this 20 meters. Becomes easier for you to search, takes less time. That's what is all about a buffer. Alright, clear friends? So buffered file IO, remember, is very, very important. Understand that, because see, file handling as a chapter, when I am taking this up, let me tell you the importance of this chapter. Programs. Alright, normally in interviews they ask you write a program for file IO, either to read a file or to write from into a file, whatever. All right. So what we will be doing is we will be discussing this particular chapter in parts, like we did with pointers. All right. Why? Because file handling is a huge chapter. All right. It will take minimum 5-6 classes for us, 5-6 sessions for us to finish up file handling. So get ready, fasten your seat belts. Let's start. First thing, what is a file? The definition of a file. All right. Let's have a definition. Here is a definition, simplest definition for you. Have a look. What it represents? A sequence of bytes. And look at that, what it says on secondary storage, that is your disk, where a group of related data is stored. A file is a collection of related data, remember that. If I am putting data together at one place, then it must be related, otherwise why am I storing it? Okay, and that again, that in that second sentence, permanent storage. Clear? Now next, come down below that, why files? Let's answer this very important question. Well, by now we understand why file. Okay, as I said, data in variables, in arrays, it's temporary, but if I am talking about a file, it's permanent. Okay, large amount of data, those are the points. You can just go through those points, nothing great about the points. All right, general points about why files. Okay, clear? Okay, now see, file is something which is, as we said, file IO, buffered file IO. Okay, input, output, whatever you are doing, buffer is there. And what we said buffer is an area in memory. Simply buffer. Got it? So inside a buffer, all these all these locations, each location will have an address, isn't it? Once again, back to pointers. Okay, if I am talking about addresses, I am ultimately talking about pointers. Got it? So here, in case of a buffer, again, memory location. So memory location means pointer. And remember one thing, let me tell you. All right, when your file is there in memory, when you are accessing the file, your file in memory will never have anything like a name or this or that. How to access the file then if my file doesn't have a name? Mind it, the moment you open the file from secondary storage, you bring it into primary storage. That is a process, we discuss about it later on. When you bring the file from secondary to primary memory, the moment you do that, the file gets inside a buffer, and you cannot access the file by name in memory. So what do I need? I need to access the file using its address. And when you are talking about address, you are talking about pointers. Now remember, I want to access an integer. I need an integer pointer. I need to access a double type value, double type pointer. Similarly, if you are talking about a file, to access and manipulate a file, you need a file type pointer. This is something very, very important, and this is the foundation to this particular chapter. Understand file type pointer, file, all caps. All right, it's a macro which defines a file. Got it? File is nothing but a macro, a predefined macro which defines a file. Okay, let's go through the definition. Okay, have a look at this slide. A pointer which is used to handle or keep track on the file which is being accessed. Okay, and what is the data type? Basically, file is not a data type, it is treated specially as a data type. All right, it is used to declare the file type pointer, and that data type is already there in stdio.h, so you don't have to do anything special. Okay, as I was telling you just sometimes back, once a file is opened, this file type pointer is the only way to access a file, okay, through the address. And how do you declare it? Very simple, and do not forget to mention it in capital. So what do you do? File asterisk pointer. That's how you declare a file type pointer. PTR is a file type pointer. So definitely the obvious question that comes up is, what is the scaling factor? Because every pointer has a scaling factor. Integer pointer, size of integer, scaling factor. Float pointer, size of float. Double pointer, size of double. So now file type pointer is something different. It depends on the type of data which you are storing in the file. Depending on that, the pointer will have a scaling factor. Suppose you are storing characters in the file, it will be 1 byte. You are storing an entire structure wise you are storing inside a file. So the size of that structure. So it depends. Got it? So that's it. File type pointer. Remember this. This is very. Once again, have a look at the slide. The file type pointer. Important. That's why. Got it? Well, all operations that we'll be doing on a file will be done using IO functions, reading, writing, all operations. We'll talk about the operations also. But remember, without these IO functions, I cannot do any operation on a file. For every type of operation related to a file, there are IO functions. Let's have a look at the table. Some functions I have deliberately not mentioned over there. Some extra functions are also there. I'll tell you about those functions later on, okay, in other parts. So don't worry about that. Just have a primary look. Just have a cursory look at name of those functions. Have a look at this table. Look at the functions. The first two, to open and close a file, F open and F close. Got it? F open is to open a file, F close is to. The syntax, the way it is used, later on I will discuss with you. Okay, this is just a partial table of the name of the function. There are so many others, remember. F open and F close are to open and close a file. Get C, put C. There are a couple of variations to this get C and put C to read what it says. Character from a file, write character to a file. Okay. Now get C, put C. Let me tell you one thing. These variations, minor variations are there. Get C, put C is there. There are some variations like get CH. Okay, have a look at this on the board. Have a look at this. To get C, you have variations like get CH is there and get CHE is there. Okay, sometimes you find alternatively these two are also there, also used. Okay, I'll tell you minor difference in syntax in using get C and get CH. And get CHE, E is for echo. What it does, you enter a character from the keyboard. Suppose you enter A, it will display A again. It echoes that character onto the screen, onto the monitor. Got it? So nothing great about it. Just know that minor variations are there. Well, something which I have not mentioned. This is for characters. Get C, get CH, etc. There are two functions, get W and put W. These two are to handle integers, which I have not mentioned in the table. I'll go back to the table. Just know the two functions are get W and put W, which are used to handle integers. Integer input, integer output. Later on in examples we will discuss that also. Got it? Okay. So again let's go back to that table, the slide. Have a look. Now get C, put C, characters. Okay. Get W, put W, integers. Okay. Now fscan, fprintf are there. Okay, I'll tell you one thing, types of data, based on types of data, I will quickly just, this is as I said, this is a partial table. So here I am writing types of data which you can directly handle through a file. For character, what are the functions we mentioned? Get C, put C, reading and writing. For integers, get W, put W. For string, you can directly handle strings. Remember that. You have something called fgetS and something called fputS. These two functions are to read and write strings. Okay. For heterogeneous data, this is something which is really important. What do you mean by heterogeneous data? Heterogeneous data means different types of data, because till now what we have been talking about, we have been talking about single type of data. Heterogeneous data can be handled using something called fscanf, which was there on that slide, and fprintf. Similarly, you have something called fread and fwrite. Now I'll briefly tell you the difference over here before we go deep into the topic. When you are looking at a file can be of two types. A pure text file, which is stored in terms of text, like if you write ABCD, it is stored as ABCD. You write anything as it is stored inside the file. But if you are talking about a binary file, remember a binary file will store the data in 0-1 format, binary digits, zeros and ones, and that file is much safer than an ordinary file. Remember that also, that is important. Okay, binary files are much more effective, much safer, because nobody can, looking at a file, I cannot read, I can't see what is the content. If I see zeros and ones only, will I sit down and translate? Not possible. Got it? So binary. Now fread and fwrite are especially used to handle heterogeneous data which is binary by nature. Okay, and another difference is fscanf, fprintf, they handle unrelated data. When I get into examples, you will understand automatically, so don't bother about that. Fread, fwrite will again handle heterogeneous data, but related heterogeneous data. That is the big difference between the two. Alright, let's go back to the other functions which are there on that slide. Have a look. You have something called fseek, sets the position to the desired point in the file. fseek is used to move the file pointer inside a file according to your need. Randomly you can access a file sequentially or randomly. Obviously, if you are accessing a file randomly, it will always be faster. So fseek is for random access. Okay, ftail helps you to it gives you the current position of the file pointer, which position it is. It gives you an offset, which is a long integer. Once we get into examples, you will be able to understand. And finally, you have rewind. Okay, wherever the file pointer is, the rewind function will take the file pointer to the beginning of the file. Okay, and quickly, apart from this, the table which you saw just now, apart from these functions, a file ends with a special character that is called EOF. Again, it's a predefined macro. EOF stands for end of file. Okay, while checking, you can simply say EOF. It's a symbol that denotes the end of a file, but it differs from compiler to compiler. So very simple, the universal one is EOF. Write EOF on any system, on any compiler, it will work, no matter what the symbol is. Got it? To check for end of file, there is a special function called FEOF function. This is used to check for the end of file. Got it? Clear? Alright. Now, apart from all this, talking about functions, couple of more functions are there which we'll be discussing later on. Apart from all these functions, let me tell you one more thing. Whenever you are dealing with a file, you'll be giving input, getting output. For this, because we said in the first place, we said it is called file IO, input output. Got it? So now what happens is, when you talk about IO, obviously IO devices are needed. Got it? C language automatically provides you with 3 predefined files which are already there, representing devices. Alright, have a look at this particular slide. std in, what it represents? Keyboard. std out, all small. std out, what it represents? The monitor. And std err, again represents the monitor, but for error messages, because if you are talking about output, your output can be proper output, it can be error also. Both of these are displayed on the monitor, so obvious enough we are talking about output. Got it? Clear? Okay. So friends, this is just a beginning to file handling. Okay, a few things we came to know. We looked at functions, we looked at all these things. Part 2, we start with how to open, how to close, and how to do various operations, and what are the various operations. Alright friends. Okay, so take care. Bye bye. In the next part, we discuss with examples. Till that time, take care.